Hi, my name is Josh Tasoff. I'm a professor here at Claremont Graduate University in the Department of Economics. I received my bachelor's degree from MIT, and I received my PhD from UC Berkeley. And today I'm going to talk a little bit about some of the projects that I'm working on. These projects are quite different, and so I want to give you a flavor of some of the things I'm doing. But I think they're similar in the sense that there's a common underlying structure that binds them all together, and I'll talk a little bit about that at the end. So first, the project that I'm going to tell you about is on exponential growth bias, and I'll start with an example. So, suppose you have a pair of rabbits, right? And this example is inspired by Trouble with Tribbles, the Star Trek episode. So you have a pair of rabbits, and it turns out that the pregnancy duration of a rabbit is about 1 month. Okay. How many rabbits, suppose that you have this pair of rabbits and they double every month. How many rabbits would you have after 1 year? Well, it turns out the number is, it's over 4,000. That's a lot of rabbits. That might be quite surprising how fast that population grew. How many rabbits do you think that there are after 8 years? Well, it turns out, you might be thinking, a lot. The number's quite big. Are you imagining a football field of rabbits? Maybe you're imagining the surface of all of the United States covered in rabbit. Both of those are actually severely understating how much rabbit there would be. The amount of rabbit there would be 730 times the mass of planet Earth. So there would literally be a planet, something around the size of Jupiter, of rabbit. And it would be a sphere, of course, because gravity would hold it together. It would be very furry and cuddly because it's rabbit. But it would be huge. It would be a massive amount. And this is quite unintuitive. It's shocking that I think after 8 years you would have something that's just almost impossible for the human mind to imagine, and in terms of its size, right? And this is exponential growth, right? And the fact that we find it very difficult to perceive this is what the literature refers to as exponential growth bias. And so what I'm working on is a model of exponential growth bias, where we're looking at how this misunderstanding of exponential processes relates to people's savings decisions. And if you think about it, every time you save money, every time you take a loan involves an exponential process because interest compounds. So this is an exponential process, right? And so we're going to make, because we have this perceptual error, we have this difficulty in understanding exponential growth, people will often make mistakes, particular kinds of mistakes, when it comes to savings and investment decisions. So this is one strand of the research that I'm working on. And right now what we're doing is we're looking at the implications of exponential growth bias for retirement savings. This is a really important question because retirement savings it's about $24 trillion in the United States. So this is there's a huge amount of wealth that's in retirement savings. And also, it's very important that people get it right, because when people retire in the United States at roughly age 65, whatever money that they have, that's what they have to survive on for the next, 10 to 15 years, maybe a little bit more than that if you're lucky. And it seems that retirement savings in the United States is quite low, suboptimally low. So understanding how people make those decisions, the decisions that they make for retirement savings, is really important for their welfare, for welfare consequences. And understanding why they make mistakes and how to help people make better mistakes can have tremendous consequences. So that's one topic that I'm working on.